Hi everyone. Very good evening, and I hope that all of you are doing really well. Please give me a plus one in the chat if my voice is clearly audible to everyone, and then I'll be starting off with this session that is complete graphs in 2 hours. So please give me a plus one in the chat if everyone is able to hear me clearly. Okay, and you can hit the like button as well. Okay, so that we can get started. Hi Rishit, hi Chem, and you can give me a plus one as well if you think that it is as cold for you in North India as it is for me. You can see I'm wearing a jacket as well. So just give me a quick plus one in the chat, and also make sure to hit the like button. Okay, and then I'll get started with the problems as well and the topic overall. Okay, so you can hit the like button first of all and give me a plus one. I'll be starting within a minute. All right. Okay. So I think that everything is working fine. So now I will try to share my screen as well. Okay. Uh, let's do one thing. Let me share my screen. Uh, all right. So just a second. Let's quickly log in. All right. So let's get started now. So basics से start होगा. Yes, it will be started from the very basic, guys. So now let's get started with this. So I had some problem with my Windows. So today I'll not be using my regular board. I have to use a whiteboard, right? So first of all, like in today's lecture, what are the things that we would be discussing, right? So the very first thing, I think it's still opening. Let me see my speed. Yeah, so just give me a second. Uh, I will, like, I'm just working on the whiteboard thing. Okay. So is there any internet issue? Just let me check that. Um, that everything is working perfectly fine for everybody. Let's get started now. Okay. So first of all, let me discuss with you the things that I'll be doing, right? So let me just open the ID and tell you about certain things. Okay. So what I will do is, first of all, let me open the IDE here, the GFG IDE. And what I'll be doing here is, let's start sharing it from here. Okay. So what I'll be doing here is, if you will see here, so the first thing is that why the graph topic is important. Okay. We'll learn about why this topic is important. Okay. After we learn that, okay, why this particular graph topic is important, then we will go ahead and see some use cases, right? Like, first of all, the first thing is that it is asked in a lot of companies, right? So we will also see some real life use cases, right? Real life use cases for graphs, right? We'll see some real life use cases for graphs, and after that, we'll solve some problems that are solved in graphs, right? We'll cover some basics, and then after that we'll solve some problems. Okay, is this point clear to everyone? Please give me a plus one and hit the like button if you have just joined, right? Is that clear to everyone? I hope that this point is clear to everyone. Is it, guys? Is it clear to everyone? I hope that it is. Okay. I hope that I am visible now. Connectivity issues. Okay. I hope that video is playing. Is video playing? Yeah, I hope that everyone is able to see my screen now, right? Uh, I think it is fixed now. Okay, so let me do one thing. Let's open this article, use of DSA in real life. Okay, let's open this article. Right. So let's see this applications. Okay, please give me a plus one. I think there was some issue from my end as per the internet, but I hope that now everything is working fine, guys. Okay. So maybe the Windows was taking some update in the background. Okay, please give me a plus one again so that we can get started. Okay, guys. I hope that everything is working fine now. All right. Great. So now let's get started with this topic and everything. And my whiteboard is also ready. Okay, so let's see here. Like, if we will see the real life use cases of graphs, let's see where are graphs used in real life. So if you will see, this article is there. I can share this link with you as well. Like, I'll just quickly copy it and paste it in the chat as well. Okay, you can have a look at it if you want. So basically, this article tells you about real life use cases of DSA. And if you will see here, so you can see that graphs are used in Facebook, right? Facebook's Graph API uses the structure of graphs. So basically, in Facebook, what happens? You know, like let's say you are a person, right? Now you are connected to somebody, right? You have a friendship with somebody. Somebody else has a friendship like this. Then you are a friend of this person. So all these things are real life use cases of graphs, right? This is one of the ways. Now you can see that Google's knowledge graph also uses this. So Google also uses it as an organization. Now next thing is Dijkstra algorithm or the shortest path algorithm. Okay, it also uses the graph data structure to find the smallest part between the nodes, right? So you must have used it in Google Maps and other things. GPS navigation uses the shortest path APIs. Okay, so there are APIs, that is application programming interfaces. They are also built on top of this. Then networking components, right? Networking components like ring topology, you must have heard. There are several other topologies also. So they also are graphs. Then Facebook, Instagram, as I said already, they also are based on graphs. Then you must have seen React. So you must have seen that there is something that is known as DOM manipulation, right? And in DOM manipulation, Basically what happens is, in DOM manipulation you have this thing, you have a tree kind of structure, right? If I'm not wrong. So again it uses graphs. Then MS Excel is what? A direct acyclic graph, right? You can see even MS Excel is a DAG. Then you can see that path optimization algorithms, BFS, DFS. Again, recommendation engines, right? Recommendation engines also use this thing. Then after that, scientific computations, flight networks, page ranking algorithms also use this, right? Then Google Map already, and Facebook suggesting mutual friends. So you can see that a lot of companies, like you can see here that like basically Google is there, Microsoft, Amazon, and a lot of companies, Uber, Ola, like all the use cases that are mentioned, all these companies must be using graph behind it. Is that clear to everyone? Please give me a +1 and hit the like button, guys, if you are clear with this thing. Is everyone clear with this thing? Is everyone clear with this thing? Like what I just said, that what are the things where the graph is used in real life? You can see, like that is why it is asked a lot in companies. Is that clear? Is the real life use case clear to everyone? Please give me a +1 and then we should move ahead as well. All right, Rishit is also giving me a +1, and you can hit the like button if you haven't already. Okay, great. So it's working fine. Right. Now after that, if you have to learn about graphs, right, if you have to start from the graphs, so basically let's see how we store the graphs, right? So if I will say, like there are two ways for storing a graph. Do you know this? Like please write B in the chat. If you are a beginner in graph, you can write B in the chat. Okay, if you are intermediate in graph, like if you have some done some medium level things in graph, so you can write medium in the chat. Okay, whatever, whichever category you belong to. How many questions you are going to solve? As many as I'm possible to do. If you are a beginner in graphs, you can write B in the chat. Okay. If you are a intermediate person, then you can write M in the chat. Okay. So a lot of you are saying beginner. Some people are also saying M. All right. Now, if I will say one more thing, right? Let's say that if you must have heard about this thing, right? In real life, if I'll talk about one more real life use case, right? Real life use case. So if I'll talk about one more real life use case, so let us say that if there is a subject, right? Let's say the subject is coded as like subject one. Okay. Like there's another subject, let's say subject two. Now, in order to complete, like in order, if you, let's say this subject is DSA. Okay, and let's say this subject one is what, like this subject one is, let's say, language. Okay, some programming language. So in order to do the DSA thing, you need to know a language. Please give me a +1 in the chat if you're clear with this thing. Is everyone clear with this thing? Yeah, DAG is also used in blockchain. Is everyone clear with this thing? Please give me a +1 in the chat. Right, in order to do a particular language, right, in order to do a particular language, you also need DSA. Like sorry, in order to do DSA you need a particular language, right? So please write D in the chat, DEP in the chat. There is some dependency, right? You can see that DSA, for doing DSA you are dependent that, okay, first of all you should do language, right? If let's say you want to, if let us say that you want to study something, let's say like physics. Okay, let's say you want to study a little bit of physics, then maybe you should do a little bit of mathematics for it, right? So first of all you'll do mathematics, then you can do physics, right? So there's something that is known as dependency, right? There's something that is known as, will this be available? Yes, it will be available after the live stream as well, right? So you can see one thing, that if I have to, like when I do mathematics, then only maybe I can do physics, right? In order to, let's say, learn about, let's say if I want to learn about something, let's say if I want to do something based on AI, right? Let's say if I want to do something in AI, then I should maybe know Python language or something, right? I should know Python, let's say, right? So this is what prerequisite, or you can say dependency, right? This is nothing but prerequisite. Okay, or you can say dependency, right? So this, all this also comes under one algorithm. Have you heard about this algorithm, guys? This is known as topological sort, right? This particular concept is solved using the topological sort. How many of you have heard about it for the first time? Please write +1 in the chat if you are hearing it for the first time. This is nothing but topological sorting, right? So you must have heard about this particular algorithm as well. So since I was telling you about a lot of, like, you know that, like you know a lot of things, I know that you know that, okay, shortest path is there, like and let's say uh, networking is there, so Facebook uses the graphs and all. But you should also know that, okay, when you have some dependency, right, so there you use the topological sort. Okay, so just do topological question today. I will be doing it, okay, as much as possible. So let's do one thing, let's try and solve one of the problems, right? So all of you know BFS, yes or no? Do you guys know BFS, yes or no? Please tell me. All of you know BFS? If you do know, please hit the like button and give me a +1 in the chat. All of you know about DSA or not, guys? Yes or no? Okay, sorry, BFS, BFS. All of you know about BFS? Okay, a lot of you know about BFS. Okay, so let's do one thing. Let's solve one problem based on it. Okay, breadth first search. Okay, okay. So let's do one thing. Let's solve one of the problems on BFS. Okay, so that we can learn about it a little bit more, right? Can we solve one problem on BFS, guys? I think that we can. Yes or no? Please tell me in the chat. I think that we can solve one problem based on BFS. Yes or no? Okay. So let's do one thing. Let's solve BFS. Okay, Khan is saying no. Why are you saying no? All right. So let's do one thing. Let's solve one of the problems that is based on BFS only. So let me do one thing. Let me just open this thing, BFG practice. So you all can also search this thing, BFG practice. Then I'll click on this particular tag here. Okay. I'll click on the problem section. Now I'll click on the topic tag and I'll search graphs. All right, and I'll be clicking on graphs. Now these are the topics that I'm having. Just a second, I need to sign in as well. Uh, and, okay, let's get started with the problem solving now. Um, okay, let's get started. All right, so these are the topics, right? So let's do one thing. Let's solve one of the problems based on this thing, right? Just give me a second. Let me find that out. Let's find an easy problem for ourselves. Okay. So let's do one thing. Let's solve this particular problem. That is BFS on graph. Okay. How many of you have already solved this? Please let me know, guys. Have you already solved it? Pankhodi Gandhi is there. Okay. Have you solved this one, guys? Have you solved this problem? BFS on graphs. Can you share the problem link? Yes, I will definitely share the problem link. So let me share it with you here. All right. No. How many of you have solved this problem? BFS on a graph. No. Okay. Some people are saying yes. Some people are saying no. All right. If you will see this particular problem, right? It was asked in Adobe, okay? It was asked in Amazon, it was asked in Flipkart, it was asked in Microsoft, Ola, Samsung, and SAP Labs, right? So a lot of companies have asked this question. So can we do it, guys? Can we do this problem? Yes or no? Okay, I'm a beginner. Right. So let's do this problem. Okay. Basically, what does it mean by breadth first search? First thing, right? So if you will see here, right? Let's say if I have opened this thing. So what is meant by breadth first search? Okay, what is meant by breadth first search? Now breadth first search, sometimes when the edge is not weighted, okay, it is used to find the shortest path. Many of the times, right, it is used to find the shortest path when the edges are not weighted. If the edges are weighted, then we have several other things, but we can discuss them later on. If, let's say, if this is a tree, right, let's say this is the tree, this is a tree. Okay, let's say this kind of tree is there. Obviously a tree is also a kind of graph. Then I'll discover the graph thing as well. But if you will see this particular thing, okay, so see, if let's say I will talk about this. So see, can I say that if, let's say, if I start from this particular node, okay, if I start from here, so what will happen, what will the breadth first search do for me? First of all, I'll cover this level. All right, first of all, I'll cover this level. Okay, then I will be covering this level. Okay, and then I will be covering this level. Okay, so first of all the nodes of the very first level will be covered, then all the nodes of the next level are covered, and then all the nodes of the next level are covered. Is this point clear to everyone? Please give me a +1 in the chat if everyone is clear with this thing. Is everyone clear with this idea? Is everyone clear with this idea, guys? uh, Please hit the like button and give me a +1 in the chat if you're clear with this thing. Is everyone clear with this thing? That basically in breadth first search, what happens? First of all, we cover the first level, then we cover the next level, and then we cover the next level. Okay. A lot of you are clear with this. All right. Now, similar to this thing, right? If I'll talk about a graph, right? So let me draw a graph for you now. Okay, let me draw a graph now. Let's say if I'm drawing this kind of a graph. Okay. Let's say if I am drawing this kind of a graph. Let's say this kind of a graph is there. Okay. All right. So let's say this is the graph that I'm having. right? So what I will do is, let's say if this is the source, right? If this is my starting point, right? If this is my starting point, then what will I do? What will I do? Breadth first search and level order are same. Yes, breadth first search is the same as level order traversal. Okay, BFS is the same as level order traversal. Now I will ask you one thing, right? If you are there, okay, and I ask you to visit all the people, right, who are closer to you, right? If I ask you to, if I let if let's say I am saying that, let's say there is some holiday, okay, or let's say there is some function, let's say there is some festival season going on. So first of all, can I say that you will visit your family, right? If you are a working professional, maybe you will visit your family. Then after that, you will do what? After that, let's say you will visit your close friends, right? Okay. Then like you will visit your close friends. Then after that, you will visit your friends of friends, right? Yes or no, guys? Please tell me. Right, this is what you will do. Then after that, another level of friends you will visit, right? First of all, the closest ones, then the closer friends, then let's say some friends, let's say some school friends after that, or let's say some, after that you'll visit some of your colleagues in your organization, right? Yes or no? This is what you will do if you are going to visit somebody, right? If I say that, okay, let's visit. So you'll say that, okay, let's say I'll visit first of all my family, then my closer friends, then my school friends or something, and then after that my colleagues and all will go. Come, yes, please write +1 in the chat. Yes or no? This I am doing for helping you to remember this thing. Okay, because I'll give you one idea that I have made by myself, that how you should think about it, right? So basically you will first of all do what? Visit this much, then this, and then this, and then this, right? This is what you will do. Now similarly, like, can I say this thing? Can I say this thing if I'll erase this part here? All right, if I'll erase this part right here, let's erase this. Okay. Now what I will do here is, if I have this part, right? So if I have this part, so first of all, can I say that I'll visit my 1 degree friend, like the closest ones, then the 2 degree, right? Then the 3 degree, then the 4 degree. Okay, basically the closer ones, then after that the next level, then the next level, then the next level. Okay, so same thing we apply in the BFS also. Okay, same thing is being applied by us in the BFS thing also. If you will see here, let's say this is our graph, right? So we have 1 here, we have 2 here, 3 here, we have 4 here, we have 5 here, we have 6 here. ओके, लीड कोड डाउन है, उन्हें कॉल करके कह दो कि सर्वर रिफ्रेश कर दे. ओके. No, I cannot do that. Right, let's say this is the thing, right? So what I will do is, if I'm starting from here, no, right? If I'm starting from here, so first of all, I'll visit this guy. Okay, then I'll visit, like, basically I'll visit these two people, right? Starting from one, I'll visit these two people first of all. Then after that, I'll visit this node and this node at the same level, and then after that, I'll visit this. Is it clear? This is my 1 degree. According to me, this is the 1 degree, this is the 2 degree, and this is the 3 degree. Is it clear to everyone? Please give me a +1 in the chat if you're clear with this basic thing. Is this clear to everyone, guys? Quickly let me know. Are you all clear with this? Is it clear to everyone? Right. This is what it means. Okay, the closest ones you want to visit. Is that clear? Please give me a +1 in the chat if you're clear with this thing. Basically, first of all, what you will do is, if you want to do the BFS traversal, so first of all, you will have 1, okay, then you'll have 2, then you'll have 3, okay, then you'll have 4, then you'll have 5, then you'll have 6. Okay, this is how the flow is going to be like. Right. Now, if I am discussing this, so how can we achieve this particular thing? That is another scenario. Okay. So, right, let's see. If you are here, so what will happen? See, first of all, what will happen? You will be at 1. Okay. Now, from 1, which other people can you reach? So, I can say that from 1, you can basically reach 2. Okay. Then you can reach 3 also. Right. Then from 2, you can reach what? You can reach nothing but 1, but 1 is already visited. Then you can reach 3 also, but 3 is also already visited. Then you can reach 4. Right. 4 is not already visited. Right. So, you will have 4. Then after that, after 2, you will go to 3, right? From 3, what will happen? From 3, you can go visit 1, but you have already visited. From 3, you can visit 2, but 2 is already visited. From 3, you can visit 4, it is already visited. But from 3, you can visit 5. So 5 will be here. Okay, then 5 will come. Then after that, when you will go to 4, right? When you will go to 4, so from 4, you can reach 2. Okay, from 4, you can reach 3. From 4, you can reach 5. Right, from 4, you can reach 6. But 2, 3, and 5 are already visited. So you will simply visit 6, right? That is what is going to happen. Is that clear to everyone? Is this point clear to everyone? Right, guys? Okay. So basically, I am doing what? Like see, I can say one thing, right? The first guy that I am seeing, right? It is nothing but first in, first out concept, right? Like if you will see here, like if you will see, like if I'll draw this again, see, if I have one, right? If I have one, if I have one, then I will push it in a data structure that is known as queue. I'll push one, right? I'll push one inside the queue, and then I'll pop it out. So I'll have one, right? Now for one, I'll visit its children. That is everybody in its adjacency list. Now one has two connected and one has three connected as well. So first of all, I'll see is two visited? No. So I'll put it inside the queue. Then I'll see from one, three is also connected. So is three visited? No. So I'll put three inside the queue as well, right? After this, what will happen? After this, there is nobody else in the uh, like in the adjacency list of one. So I'll delete, like I'll move to two. Then after that, I'll remove two and I'll put it in my answer. Then after that, from two, I will see. Okay, from two, I will see that okay, from two, which are the nodes that are already visited or not visited. Okay, so from two, what will happen? Right, from two, what will happen? I will see that okay, is one visited? Yes. Is three visited? Yes, it is already visited. Then is four visited? I don't think that four is visited, so I'll put four here, right? And after that, the adjacency list of two is also done, right? After that, the adjacency list of two is also done. Then what will happen? I will move to the next index, right? So then after that, I'll move to three. Okay, so I'll move to three. Now I'll put, like I'll have three here, right? When I have three here, so I'll see three is connected to one, but one is already visited, two is already visited, then four is already visited, but five is not. So I'll put five inside the queue, right? So whichever person is coming first, I'm taking that. Is that clear to everyone? This is nothing but the first in, first out concept. Is it clear to everyone, guys? Please let me know. Is it clear, guys? Is this point clear to everyone? Till this point, everyone is clear. Please hit the like button if you are clear till this point. Okay, Shilpi says she is clear. Right. So for this, I'm using a queue data structure. Right. I'm using a queue. A lot of people are clear, I think. Right. So what will I do? Don't worry. I will also try to cover some of the medium problems as well. Okay. As of now, I'm covering only the basic problems, but I will also try to cover some medium problems. Right. Okay. Just give me a second. Let me change the font size to, let's say, 16. All right. So let's do this here. So how will we do this particular question, right? So if you will see, like how is this graph represented as well, right? That is another thing. So basically, it behaves like this. If let's say if I have a graph, right? Let's see how it is represented. So basically, we will be given an adjacency matrix. Okay, like what does this mean? So let's say if we have a graph like this, right? Let's say we have a graph something of this kind. Okay, let's say we have what? Let's say we have one here, then we have two here, then let's say we have three here. Okay, now what will happen? Like in the adjacency list of one is connected to which nodes? Please comment down quickly, guys. One is connected to which of the nodes? Please tell me. One is connected to which nodes? One is connected to two. Okay, one is also connected to three. Right. Then after that, if you will see this node, right? If you will see two. Okay, so in the adjacency list of two, one will be present and three will be present. Then if you will see three, then in the adjacency list of three, one is already present and two is also present. Right. This is the thing. Is it clear? Right. So basically, what will happen? Every node will behave like an array. Right. Please write array in the chat. Every node will behave like an array. Right. Basically, every node will behave. Every node will itself be behaving like an array. It will be storing all the other nodes that are connected to it. Is that point? Is this point clear to everyone? Please tell me, guys. Is it clear to everyone? I hope that it makes a lot of sense to everybody. Right. Is it clear, guys? Right. So basically, this is how it's represented. Like basically, in the adjacency list of one, okay, you will be having two, three. Right. In the adjacency list of two, you will be having, like in the adjacency list of two, you will be having one, three. Right. This is going to be the thing. Okay, I think people are decreasing. Right. So let's see how we will be doing this. Okay. So we will basically have a vector and we'll name it as int. Let's have it as answer. Okay, then what will we do next, guys? Quickly let me know. What will we do? Like this is for storing the answer. Then what will we do? Like what should we do? Can anybody tell me? Anyone can tell me? See, the starting point is what? Like if you will see here, if you will see this problem. So the task is to do breadth first search starting from zero. Okay, the task is that we should do the breadth first search starting from 0. So basically, what should we do? Like basically, we will have a queue. So let's name it as q. Okay, and let's name it as int. Let's say q. I'll push what? I'll simply push 0 inside this queue. Okay, can we move a little faster? Yes, I'll try to move a little bit faster. I think the audience is expecting some harder level questions from me. Okay, so that is why. Okay, so what I'll have is like I'll have a visited array. Okay, it will denote that okay which node I have already visited. So what I'll have is I'll have visited of n plus 1 as nothing but 0. Okay, they all will be marked as not visited. Now after that, what I'll do is I'll simply mark the 0 as visited. I'll mark this node as visited. That okay, I have visited this particular node, right? Let's say there are total v nodes, right? Okay, then what I'll have is like I'll say that okay, while the queue dot size is greater than 0, so while the queue is not empty, basically till that point of time I'll keep on iterating. Okay, till that point of time I'll basically keep on iterating. Now what I will do is I'll say that okay, int x is equal to q dot front. Okay, so I'll basically take out the front element from the queue, right? I'll basically take out the front element from the queue. Then after that, I will say that okay, let's push this guy inside the answer, right? Inside the final answer. So I'll push it inside, right? Then I'll pop this. Okay, then I'll pop this particular node out. Okay. So basically what I'll do is I'll pop it out. Then after that, I'll say that okay, for int my I starts from 0. Okay, I is lesser than adjacency of x dot size, the current node dot size, and then I'll do I plus plus. Right, so I'll iterate all the through the adjacency list, and please write not visited. Okay, if there's a particular node. Okay, so let me do one thing. Let's use the auto variable here. Let's say this as auto. Let's say I is to adjacency of x. Okay, so I'll iterate through the adjacency of this particular node. Okay, x, and if it happens that the visited of I, okay, if it's equal to 0, if this guy is not visited, okay, then what I'll do is I'll mark it as visited. Okay, visited of I will be marked as 1. Okay, I'll mark it as visited, and then what will I do? I'll push it inside the queue. Please write push inside the chat. Is it clear to everyone? I'll iterate through all the nodes that are present in the adjacency list, and then if there is no problem, sir, take your own time. Yes. Is it clear to everyone? Basically, I'll iterate through every node. Okay. If it is not visited, then what I will do is I'll simply say that okay, let's mark it as visited, and let's push this guy inside the queue. Okay, what does auto mean? Not good at C++. Basically, this is to indicate that like if let's say adjacency of one is there, adjacency of x is there, okay, and it is having the nodes let's say as 4, 5, let's say 1, okay, let's say 3. These are the nodes. So auto I will do what? One time I will be at 4, okay, then I will come at 5, then I'll come at 1, and then I will become 3. So auto will help me like one time I will be equal to 4, okay, next time I will be equal to 5, next time I will be equal to 1, okay, next time I will be equal to 3. So is this clear? Is this point clear to everyone? Like what does the auto variable do in C++? Similar kind of thing you can do in your languages also, or you can write int I also, that will also work possibly. Is that clear to everyone? I don't know why I'm getting a lot of ads today. All right, guys. Is that clear? Understood? Please give me a +1 if you have understood till this point, right? Once I have done the traversal, right? So basically, what you do, you basically initially you push 0 because you'll be starting from a source node that is 0, right? Then I have a vector int answer for storing the final answer. I have a queue, okay, that is of int size. I have a visited array for storing whether a node is visited or not. Okay, initially I mark the 0 as visited. Then I will iterate until the queue is not empty. I'll take out the front guy, okay, and I'll push it as the answer inside the vector, final vector, and inside the final array list, you can say. Then I'll pop it out, and then I'll iterate through the adjacency list of this current node. Okay, what is the meaning of adjacency of x? Basically, adjacency of x, as I said, if I'll move back to this, right? So let's say if I have 1, if I have 2, okay, then I have 3. If I have all these nodes, right? If 1 is there, okay, and 1 is connected to 2, 3. So basically in that case, adjacency of 1, okay, will behave like 2, 3. So basically all the nodes that are connected to it, that will be considered. Is that clear to everyone? Now, is it clear to all of you? What is the meaning of adjacency of x is, yeah, so basically all the nodes that are connected, right? Now, if I'm iterating through all the nodes, right? So if that guy is not visited, Then I'll mark it as visited and I'll push it inside the queue. That is what BFS means basically. In the end, what I will do is I'll simply return nothing but what? I'll simply return nothing but this particular thing, the answer. Is that clear? I hope that this point makes a little bit of sense to everybody. Let's try and quickly compile it. It is adjacency list. Yes, it is adjacency list. Yes, definitely. Okay, so it works on the samples. Let's try and submit this also and see if it gets accepted or not. All right. So this problem does get accepted, right? You can see that obviously I've solved it a lot of times, so it gets accepted. So please write AC in the chat. Okay, please write AC in the chat, and then I'll solve one more good problem based on this, right? Please write AC in the chat, and then I'll solve one more good problem on it. Let's write AC in the chat quickly, and then I'll be solving one more problem on this topic. Okay. All right. Let's can we move to one medium problem? Please write medium in the chat. Okay. Can we move to one medium problem based on this topic? Okay. Try with matrix. As of now, I'll not like my adjacency list will be given, then I'll try with the adjacency list only. Okay. Now let's do one medium problem. Okay. So I'll do one thing. Let me open this board. Okay. And let me open the problem as well. Just give me a second. Till then, you can give me a +1 if you have understood till now. Okay. Just a second. I'll open it. All right. Now let's do one more basic problem. It's not that basic, but it will still help you to level up. Okay. Level of nodes. Let's write GFG practice. All right. So yeah, let's open this one. Let's have a look at this particular problem. Okay. Now let's see what does the problem actually say. Right. Let's see what does the problem actually say. So problem says that level of nodes. Okay. So by this we do understand that what is it expecting from us, right? So let's say this is the graph. So let me quickly copy this image and let's try and paste it somewhere here. Just a second. Uh, okay. Just a second. I'll just open it again. I don't know why it's taking some time. Okay. Yeah, fine. Now let's get started. Right. So basically, this problem is nothing but level of nodes. Okay. We'll do this problem and then we'll enhance further. So let me do this one. Level of nodes. Now, what does this problem say? How many of you have done this problem? Please write yes in the chat. Have you done this problem already, guys? Yes or no? Please tell me. Has anyone done this problem? Has anyone done this one? Okay. Can you share the problem link? Definitely, yes, I'll share the problem link as well. So here's the problem link. Okay, a lot of you are saying no. So previously, if you will see, this problem has been asked in some companies. Also, that is not although that is not mentioned here. So let's have a look at this particular problem now. Okay, so the problem says that you will be given an undirected graph with V vertices and E edges. So what you have to do is you have to find the level of the node. If X does not exist in the graph, then you have to return -1. Okay, so let's say this graph has been given to you. Okay, so let me paste this graph. I hope that I can paste it. Okay, I cannot. Let me see if I can copy this image now and paste it. Okay, so it does get pasted. All right. So let's say this is the graph that has been given to me. Okay. Now, if you will see in this graph, X has been given as 4. Okay. So basically, X is equal to what? X is equal to 4. So this particular node we are talking about. Can you tell me what is the level of this node, guys? Can you tell me what is the level of this node? If I start from the level, let's say 0. Okay. If I am starting that, okay, this is level 0. Okay. Then this is level 1. Then what is the level of this node 4? At which level this node 4 is present? Please quickly comment down, guys. Please quickly comment on at which node this particular like at which level this node is present. Okay, please write 2 in the chat. So it's present at level 2. Mukesh, it is present at level 2 basically. Right. This guy is present at the level 2. Okay. this guy is basically present at the level number 2, right? So if this guy is present at the level number 2, so what can we do further, right? What can we do further from here? So if you will see, can I say that this is nothing but BFS? Please write BFS in the chat, because level, we have to do level order traversal, no? Like we have to do level order traversal. That is how we will get this thing. Please write level in the chat. Please write level in the chat or LO in the chat, right? We should do level order traversal, right? If obviously this is a tree, but basically indirectly, if let's say we are given a graph, so you have to tell the level. Let's say if this kind of a graph was there, right? If I'm drawing this kind of a graph, let's say this was there, okay? If a graph of this type was there with me, let's say this kind of a graph was there, okay? Let's put some data inside. So let's say this was 1, this was 2, okay, this was 3, this was, let's say, 4, this was 5, and this was 6, okay? And let us say that there was another node inside. Let's say this was 7, okay? So if I ask you that, okay, tell me for if I'll ask you that, okay, tell me for this particular node, let's say for the node x is equal to 7, right? For the node, let's say x is equal to 7. What is the level of x is equal to 7? Please tell me. If I'm starting from this node, what is the level of of the node x is equal to 7? Please tell me, guys. Quickly let me know in the chat and hit the like button if you already know it. What is the level of this node 7? Please tell me. What is the level? What's the level of this node? Okay. If you will see, this is what? Level 0. This guy is level 1. Okay. This guy is level 1. This guy is level 2. Okay. 2. It is nothing but 2. But how? How did you find this? How did you find this? Can anyone tell me? How did you find this thing? How did you found this thing? Interesting. But how did you found it? How did you found it? Can I say that? Can I say that? If I am at a current node, right? So see, if no, I did not like see. If you will see normally, now. So see, if I am at a particular node, right? So if this guy has a level is equal to 0, right? So if I am going from this node, if I'm visiting the next node, so its level will be my level plus 1. What do you think? Please write plus 1 in the chat. Okay. If I am at this node, okay, and from this node I am visiting, if I'm at a particular node, okay, and let's say its level is L, okay, if I'm at a particular node, if you will see, if I'm at a particular node and its level is L, okay, then the level of next node will be L plus 1, right? If I'm at a particular node and I reach the next node from it, so its level would be level plus 1. Is that clear? L plus 1, current level plus 1. Is that clear to everyone? Please give me a plus 1 in the chat if you're clear with this thing. Obviously we will be using the BFS technique for this, but can I say that the logic is that if we are at a particular node and the level of it is L, then if I'm going from that node to another node, then the level would be L plus 1. Yes or no? Please give me a plus 1 in the chat if you're clear with this thing. Is everyone clear with this idea, guys? Okay, is everyone clear? Please hit the like button and tell me. Yes, so Subodh is writing the clear thing that I need to do this, right? So see, basically earlier what we were doing, right? Earlier I was saying, like earlier what were we doing in our approach, right? Earlier in the normal BFS, right? Can I say that we were only having the node? Please write node in the chat, okay? In the normal BFS, inside the queue, we were only storing the node. Please write yes in the chat or node in the chat, right? Please write node in the chat. Everyone, please write node in the chat. Then obviously we will move to some more better problems compared to this one, okay? Please write node in the chat, everyone, and hit the like button as well. Okay. So earlier we were storing the nodes, right? But now can I say that I need two informations, right? Because see, if 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 I am going from this node to this node, okay, so I should know that okay, earlier I was at this node, okay, but I should also know the level, right? One more parameter that should be there with me is the level. Please write level in the chat, okay. I should also know the level because from this node one, like it has a certain level. So if I'm going to the next node, so I'm going to this node 2, but it will now have the level as level plus 1. Yes or no? Right. So that is what I need. Yes or no, guys? Please tell me. What do you think, guys? Is that clear to everyone? Is that clear to everyone? Like basically, if I'm at this node, okay, and it has a certain level. So if I'm going to the next node, so it will have the level as level plus 1, right? So I'll go to the next node, right? So if I go to, let's say, this node, so it will be the node 3 and it will have the level as level plus 1. Right. This is going to be the only change. Is it clear to everyone? Right. Now let's say that if I have a graph of this kind, let's say if this is the graph, okay, let's say this is how my graph looks like, right? Let's say if I am putting some values here, so let's say this is 1, this is let's say 1, okay, let's say 1, okay, let's say this is 3, let's say this is 5, this is 7, okay. Now if I'll ask you that, okay, what is the level for x is equal to, let's say something like 4, What is the level for the node x is equal to 4? Please tell me. Please tell me. Guys, what is the level of this node x is equal to 4? Please tell me. Please tell me. What is the level of x is equal to 4? Hi, Naikach. What is the level of node x is equal to 4? Please tell me. No, minus 1. There's like actually for it, there is no level existing, right? So please write minus 1 in the chat. Please write a quick minus 1 in the chat, right, guys? There's no level existing for it actually. So please write minus 1 in the chat and hit the like button as well if you are clear with this thing, right? So there's actually 4 is not present in the graph. Yeah, right. So for that, you have to return minus 1. Okay. Now, one more thing. Like, tell me in this BFS graph, how many levels will be there? Like, can I say that if I look at this graph properly, so possibly this is one level, right? Let's say this is let's say this is level 0. Okay. Let's say this is level 1. Let's say this point is level 2. Right. This is going to be the thing. Right. Is that clear to everyone? Is that clear to everyone? Right. So, is that clear? Yeah. So basically, there are three levels, right? There are three levels starting from level 0, let's say level 1, level 2. Okay. If I'm starting from 0 based index, right? That point is clear. Pretty much clear with this, everyone, right? So level 0 is there, level 1 is there, okay, and then level 2 is there. So basically, there are three levels in this particular graph, right? Now, if I will see the same thing, right? If I'll see the same thing right here. So let's say that if I'll have this problem, right? So if I have this problem, I don't know why it is not looking proper. Okay. So basically, if I'll talk about this one, right? So can I say that in my queue, what will I do? Right? In my queue, right? In my queue for this problem, as I said, if I'm at a node X, okay, and I'm going to the node Y. So if this node's level is L, so the level of next node will be what? L plus 1 if I'm going from here till here, right? So this node is X, it has a level this. So now next node will be what? Y and level plus 1. So basically, please write pair in the chat, okay? Inside my queue, I will need a pair because I want to store the node, okay? And I also want to store its level. So please write level in the chat. Okay, please write NL in the chat if you're clear with this thing, right? Is everyone clear with this thing? I need the node as well as the level, right? Please write pair in the chat if you're clear with this thing. Is everyone clear with this idea? I need the node as well as the level, right? Is that clear to everyone, guys? Please hit the like button if you're clear with this point, right? Please hit like and give me a plus 1. I'm just waiting for a minute. Okay, is everyone clear with this? Okay, all right. So I hope that most of you are getting this idea, right? So what can be done here, right? What can be done? So if you will see here, like basically I can do the BFS thing again. So I will have a pair, right? So you can make a custom pair for yourselves. Okay, I'll try to show the Java code. Let me see if I have the Java code. I hope that I have. Okay, so please write Java OP in the chat. Okay, so you can see that I have submitted the code in both C++ and Java language also, right? So initially I'll be coding in CPP, right? I will write the code, okay, in C++. Okay, I'll write the code in C++, but I will show the Java code also. Please write Java OP in the chat. Okay, if everyone is fine with it, right? I'll show like basically what I'll do is I'll give you the I'll write the code in C++, but I'll show you the Java code as well. Okay, if you are okay with this, I hope that Java people are also okay. I cannot write in Python. I am not so proficient in Python. Okay. So what will we do here, right? What will we do here? Can I say that we'll have a queue, right? Q U E U E. Okay. Let's name it as int, comma int. Okay, and let's name it as queue. Right. This is what I'll be having. Basically, I'll be having a queue. Sorry. Let's have it as a pair. Right. So basically, I'll be having a queue that will behave like a pair. Okay. So basically, what I'll have is I'll have a queue that will behave like a pair. Let's say something like this. Okay. Now what I'll do is I'll simply push. Initially, what I'll push is let's see where from where it is starting. It is starting from 0 vertex. Okay. So let's do one thing. Basically, if you will see here, so my graph like it is starting from 0, right? It is starting from the node 0 and the level is 0. Please write 0 comma 0 in the chat. Is everyone clear with this thing? Initially, it is starting from what? 0 comma 0. Right. Initially, it is starting from where? It is starting from 0 comma 0. Hi Abhishek. Very good afternoon. Right. So what will I do now? If you are here, so what can I do? Like I can simply say that we'll try to run a while loop, right? But do I need anything else, guys? Please let me know. Do I need anything else? Yes. I need a visited array as well, right? I need an int visited of v plus 1, let's say, is equal to 0. So basically, I need to mark all the cells initially as not visited. Okay, then I'll have the visited of 0 as 1. Okay, basically, I'll mark 0 as visited, right? And then I'll say that, okay, while the q dot size is greater than 0, while the queue exists, basically, while the queue size while my queue is not empty, till that point of time I'll keep on iterating. Okay, now what will I do here, guys? Please tell me, what will we do here? Like, I can say that, okay, if like basically I'll take it out. So let's say if I'll store it in form of a pair, so pair of let's say int uh, comma int, right, p is equal to pair of int comma int, p is equal to what, q dot front. Okay, so I'll take out the front of the queue and I'll then pop this, right? Now I can say that, like, int, let's say the current node. Okay, the current node, let's name it as current. Okay, so the current node will be what? It will be p dot first. Okay, it will be the first part. Please write first in the chat. Okay, the first part will always indicate the current node. Okay, and the second part of a pair, right? So second part will indicate the level. So let's name it as level is equal to p dot second. Is that clear to everyone? Is this point clear to everyone? Please write yes in the chat if everyone is clear till this point. Is everyone clear with this? Please hit the like button, guys, if you are clear with this point. Okay, is everyone clear with this idea? So basically what I'll have is I'll have q dot front. Okay, I'll pop it, and then I'll have the current level and this guy, right? Now what I will do is I'll say that, okay, for let's say auto I is to uh, like I is to adjacency of this node, right? The current node. I'll iterate through the adjacency list of the current node. Okay, and what will I do now? I'll iterate through the adjacency list of the current node. Okay, uh, if it happens, right? If it happens that let's say if this thing happens that I dot sorry, if the if my, let's say my connection is not visited. Okay, if it is not visited, okay, then I'll mark it as visited, yes or no? Like, I'll mark the visited of the this particular node as 1, right? Yes or no, guys? I'll mark it as visited, and I'll say that, okay, I'll do what? I'll do q dot push. Now I'll push the ith guy, and what will be the level that I'll push? Okay, if this ith node was not visited, okay, in my adjacency list, if this ith node is not visited, okay, then I will mark it as visited. I'll visit it. I'll push it inside the queue, and along with it, what will I push, guys? Quickly let me know. I'll push the level as level plus 1. Please write level plus 1 or L plus 1 in the chat. Is it clear to everyone? Is it clear to everyone? This is what I'll try to do. Is it clear, guys? Please let me know. Is this point clear to all of us? I hope that it is clear. Please write L plus 1 or plus 1 in the chat. If everyone is clear with this point, please give me a plus 1 in the chat, guys. Okay, then we'll proceed further with this one, with this part. Rohan is saying yes. What about other people? Others are also clear with this, right? So another thing that I need to see, right? Another thing that I need to see, let's say if the current node that I'm at, okay, if the current node that I'm at, if it's equal to the node X that I was looking for, okay, if it is equal to the node X, then can I say that I'll return that particular level? Yes or no? Please write yes in the chat. If let's say the current node that I'm at, if it is equal to X, right? If the current node that I'm at, if it is equal to X, then can I say that I'll directly return? Explain with example and showing traces. Okay, so actually that will take a little bit of time, so that is why I'm not doing it. Is that clear? I hope that imagination of BFS is a little bit clear because I explained it in the starting. So if the current node is equal to X, then can I say that I'll return its level? Yes or no? Okay, where is, what is X here? X is the node. If you will see, like, let's say this is what, this is 1. Okay, this is 2. Let's say this is 3. Okay, let's say this is how the like, let's say this is how the tree looks like. Let's say this is 1. Okay, this is 2. This is 3. This is 4. This is 5. This is 6. Right, so let's say if I tell you that, okay, X is equal to 3, so basically this is the node for which I'm looking for the level. Okay, can you explain it in Java too? Yes, I will try to explain it in Java too. Is it clear to you, Rohan? What is X? X is the node for which I want to find the level of. Is that clear? Is that clear to everyone? Okay. So what will I do here? Like, if I reach this, just a second, here is the question. All right. So basically, if the current is equal to X, then I'll return that particular level. Okay. Otherwise, I'll keep on iterating, and in the end, if I'm not able to find, so I'll return -1. Is it clear, guys? Is this point clear to everyone? Is it clear to everyone, guys? Quickly let me know. Like if I'm not able to, like if I do the whole BFS and I'm never able to, like whenever I reach the current node, so whatever level it is at, I need to return that level. Is it clear? Please write level in the chat if you're clear with this thing, that whenever if I reach the current node X, then I'll return that level. Okay. Otherwise, I'll keep on doing the BFS traversal until the queue is empty. And if I reach the end of the queue, right, and I'm not able to find, if I do my BFS throughout the whole graph and I'm still not able to return any level, so in that case, I need to return -1, indicating that the node does not exist, right? Does not exist, right? So I'll say that, okay, it does not exist in the graph, right, guys? Why are you doing q dot pop? Because as I said, let's say if you have certain nodes, right, if you have, let's say, one is there inside your queue, right, so then you pop it out, you push it as the answer or whatever, then you have two, then you have three, so then you pop out two also. So basically you need to pop them out so that always you can access the front guy of the queue, right? That is why we do this thing. Is it clear? Share the problem link, please. Okay, I'll try to share it again. Okay, I'll show you the Java code also, don't worry. All right, so let me do one thing. Now let's try and compile this problem, okay, to see if it works or not. Can you explain again which part you want me to explain, Sovan Chamka? Which part you want me to explain again? If all of you are clear till this point, please hit the like button, guys. Okay. Langer OP. Hi, Langer. Okay. So see, basically, you can see that for this sample, we are getting the right output. So I think that you can watch the recording, Sovan, for the previous question. Okay, this gets accepted. So is this problem clear to everyone? Please write AC in the chat. If this problem is clear to everyone, please write AC in the chat. Is it clear to everyone? Please write AC in the chat and hit the like button. Okay. If this problem is clear to everyone, please write AC in the chat and hit the like button. Okay. You can write AC in the chat if this problem is clear and you can hit like. Then I'll proceed further as well. Yes, it was an easy problem. I would say that it was an easy problem as well. Okay. So now I will show you the Java code also for it. Just please write Java in the chat. Now I'm going to show you the Java code as well for this problem. Okay. Just give me a second. I'll just copy this. Okay, let me show you the Java code. Right. So see, basically, if you will see, like I was using a pair. Now see, if x is 0, so if I'm having x, the node as 0 itself, so I'll return 0. Like it will be at level 0 only. Otherwise, I'll have a pair. So please write class in the chat. Okay. Here, if in C++, pair is already defined. Right. Pair is already defined as a template. But in C++, if I have to make the pair, so I'll make a class pair. Okay. In that, I'll have two data types. Right. I'll have the node and I'll have the level. Right, I'll have a constructor in which I'll be having the node and the level. So I'll initialize my node and the level always. Right, will you take live at weekend, sir? I do take live on the GFG practice channel. Okay, you can basically do one thing. We do take lives. Like there's one channel that is named as GFG. Okay, practice. So you can subscribe that channel. Okay, on that channel we take live every day, not one day, not 2 day, not weekends, but we take every day. So please make sure to subscribe GFG practice if you want to. Okay, so basically I'll have this pair. So this is the queue declaration. Then this is how I'll make a new pair. Okay, so the new pair will be obviously 0 comma 0, and then I'll add this pair. I'll have a visited array for v nodes. Initially I'll mark all of them as 0, then I'll mark the 0th node as visited. Is it clear to everyone in Java also? I hope that everyone is able to see this. Is it clear till this point, everyone? Please hit the like button, everyone, if you are clear till this point, right? Okay, now if the queue size is greater than 0. If the queue is not empty, then I'll have this pair. Okay, so I'll remove it from the queue, I'll pop it out, and I'll have it. Now the current node is what? The paired, or like for this node, for this pair P, its node, that is what I'll store. The level will be what? P dot level, right? Pair dot level. So then I'll iterate through the adjacency list, and I'll say that if my connection is not visited, then I'll mark it as visited. Okay, if my connection is X, then I'll return level plus 1. Otherwise, I'll put it inside the queue as by making it as a pair. Is it clear to everyone? Please write yes in the chat, guys. And then I'll proceed further to another problem as well. Is it clear to everyone? Please let me know, guys. Is this problem clear to everyone? Quickly let me know, and then I'll proceed further. Is it clear to everyone? Then we can proceed further also. Okay. So a lot of you are clear with this. Right. So please hit the like button, guys, if you have understood everything till now. Okay, so please give me a +1 in the chat and hit the like button. Okay, let's have a look at the counter. So please hit the like, and then I'll move to the topological sort also. Please hit the like button, and then I'll move to the topo sort also. Okay, please hit the like button, so such that I can move to the topo sort. Okay, so I'll explain you some more problems. Let's say after this, I'll try to explain you topo sort also. Please hit the like button. Let's say that, let's see if we can reach 105 likes or not. Then I'll proceed further. Okay. Uh, Please hit the like button. I'm just waiting for 30 seconds more, and then we'll proceed. I still cannot see the like counter going up, so let's see. Which topics are important in graphs? So topological sort is another interesting topic that's very important, right? So now let's see this, right? So please write topo in the chat, topo OP in the chat. Okay, topo, like now we are going to discuss the topological sort. Okay, that is nothing but the dependency. So please write dependency. What an explanation. Thanks a lot, Vishal. If everyone is happy, then after this video is over, you can write understood in the okay. So this is nothing but the dependency thing, right? Topological sort is nothing but dependency, right? Dependency. Sorry. Topological sort is nothing but dependency, right? Like if I'll say that, okay, in order to complete the semester 3, right? In order to complete your semester 3, you need to pass in, like in order to go to semester 3, you need to first of all pass semester 1. Yes or no, guys? Right? So this is one, like a sort of dependency. In order to learn DSA, right? In order to solve some DSA problems, you need to do a particular language, right? So that is what dependency is all about, right? Please write DEP in the chat. Okay, dependency. This is nothing but dependency. Is it clear to everyone? Dependency. This is what dependency means, right? Is it clear? Okay. Is that clear? Please write DEP in the chat. Please write dependency in the chat. Okay. Dependency thing is going to be pretty important for us. So please write dependency in the chat. Please flood the chat with this dependency thing. Okay. You have to do two things. You have to hit the like button. Okay. And also you have to write dependency in the chat. Okay. In the chat, you have to write dependency and you have to hit the like button. Then I'll proceed further. Then surely I'll proceed further. Okay. Now talking about this, right? So what will I do? What will I do now? So what's the agenda for the next 1 hour, right? For the next 1 hour, uh, I will try to cover these things, right? So what I'll do is, like, we will learn about the topo sort. Okay. So topo sort inside out. Let's say I'm talking about the Kahan's algorithm, right? Let's say we'll learn about the Kahan's algorithm. Then what we will do is, after that, we'll solve the Kahan's algorithm. We'll write the code for it. Okay. Then after that, I will do one hard problem. Okay, one hard interview problem. Okay, and you can write dependency in the chat again, because there we will see that, okay, there is some dependency, that is why we are doing it. Please write DEP in the chat. Okay, what we'll do is we'll identify that, okay, there is some dependency, right? Okay, you must have seen that, okay, in order to complete, let's say, in order to do, let's say, course 1, like in order to do, let's say, course 3, you need to do the course 1 and all that stuff, right? So that is what dependency in real life means, right? Where is this topo sort thing used in real life? Anyone? Topo sort used in real life? Any example? Anyone can give me example? Anyone can give me example where topological sort is used in real life? If you know about it, you can write yes in the chat. Otherwise, please write no in the chat. Okay, based on this, we'll proceed further. Okay, do you know where topological sort is used in real life? Yes or no? Yes or no? Okay. If yes, then tell me. You have to, if yes, then you have to comment. Otherwise, you can always write no. Okay. So, can you tell me, Subodh, where topological sort is used in real life? Topo sort is used in real life. Sumon, you can also tell me. Where is it used in real life, guys? Please tell me. Where is topological sort used in real life? Okay. Anjali saying that she does not know. Right. So, if you can just go, have a Google search. So, topo sort. Let's say topo logical use in real life. Okay. So if I'll search this thing, right? So you can see that it is used to find cycle. Okay. Operating system deadlock. Deadlock. Okay. University course. No, no, no. See, operating system deadlock. Right. Have you heard about operating systems? Right. Please write +1 in the chat. Have you ever heard about deadlocks? Right. Deadlock in operating system, right? You must have heard about deadlock, right? So that is also one of the areas where you use this topo sort, right, for deadlocks, right? Dependency resolution, again, topo sort, right? Then if you have to see manufacturing workflows, this data serialization, context free grammar. So basically, wherever you like, this is one of the best examples where this is used. So basically, whenever you have to do some kind of, let's say, reverse engineering, or to be simple, you can say that whenever you have to find that, okay, if this task had to be done, then after that this task was done, this task was done. So if you want to identify those things, that is where topo sort comes into play, right? Okay, so that is the thing. Now let's do one thing. Like, first of all, topological sort is applied in direct acyclic graph. Please write DAG in the chat. Okay, and hit the like button, guys. Hit the like button. Topo sort is basically used in direct acyclic graphs. Okay, topo sort is basically used in direct acyclic graph, guys. Okay, topo sort is basically used in directed acyclic graph. Now what does directed mean? If let's say this, from this there is a node u, okay, this node is v. Now if this is undirected, okay, if this is undirected, if this edge is undirected, then this means that, okay, you can go from u to v. Okay, you can reach from u to v, and you can also reach from v to u, right? You can go from u to v, and similarly you can go from v to u. This is what undirected means, right? But if let's say there is this node, okay, and there's this another node, let's say this is u, this is v. Now if this is directed, right, if this is like this, if there's an arrow, like, let me use another thing. Let's say this is u, let's say this is v. Okay, this is the node, this is another node. Now if you're having an arrow, right, so this basically, what does this mean? This means that, okay, from u to v there's an arrow, so you can go from u to v, but you cannot go from v to u unless and until there is another arrow that is going towards, right? So this is directed. Please write dir in the chat. This is nothing but directed. Please write dir in the chat. Is it clear to everyone? Is this point clear to everyone? Please hit the like button if you're clear till this point, guys. Okay, now what does, like, we discussed that, okay, topological sort is applied in directed. Okay, so I hope you are clear with directed, and you are clear with the graph thing also, right? Direct acyclic graph. Now that is DAG overall. Now what is this thing? What is this acyclic? Okay, so what is cyclic? Let me see. Like, if let's say from 1 I'm having a node to 2, okay, then I'm having 3, okay, like arrow like this, then this. Now let's take a real life example. Let's take an example of politics, right? Politics, right? So can I say that in politics, let's say this party is blaming that, okay, this thing is because of this political party. Then this political party is blaming that, okay, this thing is because of them. Then this political party is blaming that this thing is because of them, right? Or let's take one more basic example in our lives, right? Let's take one more example, right? Let's say that if you go to, like, SBI, right? Let's say if you go to SBI, right? So can I say that if there is this counter, right, then this counter sends you to this counter, then this counter, this person sends you to this person, then this person sends you to this person, right? Then this person sends you to this person, right? There's some cycle, right? It keeps on repeating. Have you seen this thing? Very basic thing, right? You must have seen it. Yes or no? Right? Whereas when you go to the private banks, your work does get done, gets done very fast. Yes or no, guys? right? So that is what cyclic nature means, right? Can you please discuss about the Dijkstra? If possible, if I'll reach there till that point, then I can. I'm not sure whether I can or not. Okay. So is it clear to everyone? Right. Basically, directed acyclic graph means what? This is cyclic. Right. This is cyclic. Right. Because for doing one, you need to do two. For doing two, you need to do it two, three. Right. For doing one, you need to do two. For doing two, you need to do three. For doing three, you need to do one. Right. So that is not a good thing. Right. That is cyclic. But if I'll talk about acyclic, right. So basically, let's say if I talk about this one, right. Let's say this is one. Let's say this is two. Okay. Let's say this is three, and let's say this is 4, right? So now this is not, this is acyclic, right? This graph is acyclic because there is no cyclic dependency, right? This is not cyclic. This is not cyclic. Is it clear to everyone? What do we mean by be cyclic? Like, let's say if this was 1, this was 2, okay? Then if I was having an arrow like this and then like this, so this is cyclic, right? This is cyclic. This is cyclic. This graph is cyclic. This one is acyclic. Okay, is it clear to everyone? Anyone has got doubts in the cyclic acyclic thing, please let me know. Otherwise, we'll proceed further with the next part. Anyone has got doubts with this point, please let me know. Otherwise, I'll proceed further as well. All right. Okay. So is everyone clear with this till this point? Okay. So let's move forward. All right. Let's move forward. So what will I do? Let's say that if I have a graph, let's say if we talk about topo sort, let's do one thing. Let's open this. So topological sort. It will open this up. Uh, right. Let's have this problem. Finding cycle in graph, operating system, deadlock, detection, sentence. Yes, a lot of things. Let's do this problem. Okay. Let's have a look at this problem. Let's do this problem topo sort. Just a second. Control or Control C. And let me paste it as well. Can we start with this problem, guys? Okay. Okay. Great, Vishal. All right. Okay. So just a second. If everyone is clear till this point, because now I'm going to solve that problem. So please open it in your laptops as well. Okay. Right. So DU is saying let's start. Yeah, Anjali is saying yes. So let's get started with it as well. Okay. Uh, right. So let's get started with this. Right. So let's see. Basically, please write Kahan OP KHN. Right. Like let's see this KAH. Yeah, Kahan. Right. KHN. Please write Kahan OP in the chat. This is nothing but Kahan's algorithm. Okay. Kahan's algorithm. It is again based on PFS, right? It is again based on PFS, right? So please write Kahan in the chat, and then I'll start with the Kahan's algorithm. That is nothing but topological sort can be done in two ways, but I will use the Kahan's algorithm as of now. Okay, Kahan's algorithm. Can we proceed further? Basically, it's not. It's like you can see here. If I'll search KHN, like KHN, right? So see KHN is like you can see this. So Kahan's algorithm KHNS, right? KHN apostrophe S. Right. So what is this algorithm all about? Right. What is this algorithm all about? So let's have a look at one of the graphs. Let's say if we have a look at this graph. Okay, let's have a look at this graph. Right. So if you will see here, if I'll copy this one, just a second. So I'll quickly copy this one. Copy the image. Okay. Now let's paste it here. Okay. So now let's do one thing. Let's see. So like there's one concept of in degree. Okay. It works on the concept of in degree. Right. Please write in the chat. Okay. Please write in the chat. Okay. There's something that is known as in degree. Now what is in degree and what is out degree? There's something that is known as in degree. There's something that is also known as out degree. Okay. There are two things. There's something that is known as in degree. There's something that is also known as out degree. Right. So if you will see here, if you will see here, so if I'm having this thing, right? So what does in degree mean, right? So if let's say there is a node u, Okay, and let's say there is a node u, right? Let's say there is a node u. Okay, and let's say there is another node v, right? And from u to v there is an edge going, right? So basically what will happen to, can I say that there is an edge going towards v, right? Edge going towards v, right? Like there is an edge going towards the node v. So basically the in degree of v will be increased, right? In degree of v will be increasing. Okay, then if you will see for this node u, right? So u is having an edge towards v, right? U is having an edge, there is an edge coming towards v, so that is why its in degree is increasing. But if you will see for u there is an edge going from it, so basically out degree of u will be increasing. Is that clear? Is that clear? If there is a node, like if they from u there is a node going, like if there is an edge going from u, then that will be called as the out degree of u. Okay, that will, in that case we'll say that okay, out degree of u is increasing, right? If there is v, if there is a node v, let's say, if an edge is coming towards it, then we'll say that okay, in degree of it is increasing. Is that clear to everyone? When does the session start? It's Vaishnavi, this session started at 10 p.m. today. Okay, so is it clear to everyone, guys? Is it clear? Now tell me this thing, just give me a second. Okay, let's do one thing, just give me a second. Okay, now what is if I'll talk about this thing now, right? Let's talk about it again. So basically what I'm talking about, see, if if this particular node is there, right? If this node is 5, let's say there's an edge coming from 1. Okay, let's say there's edge coming towards 2. Let's say there's an edge coming from 3. Okay, let's say there's an edge coming from this node 4, like let's say 7 also. So what is the in degree of 5? Tell me guys, what is the in degree of 5? What is the in degree of 5? Please tell me. Please quickly comment on what is the in degree of 5, guys. What's the in degree of 5? Tell me. What's the in degree of 5? What's the in degree of this node 5? 4, 4, 4, 4. Basically, 4 nodes are coming towards it. 4 nodes are coming towards it, right? So that's why it's nothing but 4, right? That's the thing, right? So what can I say? What can I say? Like, see, if you will see here, let's say from 1 there is an edge going towards 4, okay, and from 1 there is an edge going towards 3 as well, right? So because nodes are pointing, yes, definitely. So see, if you will talk about this thing, right? So if I'll see in the adjacency list of 1, can I say that 4 is present, okay, and 3 is present? Please write 4 comma 3 in the chat. Please write 4 comma 3 in the chat, guys, in real quick time, if you're clear with this thing, right? Can I say this, guys? Can I say this thing, right? Please write 4 comma 3 in the chat. In the adjacency list of 4 is present and 3 is present. So let's say this is the current node, okay, and these are these are my I, right? These are my neighbors, right? So I'll say that okay, in degree of this ith guy plus plus, please write plus plus in the chat if you're clear with this thing, right? So I'll say that okay, in degree of this guy, if I is 4, so it's in degree plus plus, in degree of again I when I is 3 plus plus, right? Are you clear with this thing? Are you clear with this thing? That's how I'm going to increase the in degree of all these people. Is that clear to everyone? Is that clear to everyone? Please write plus plus in the chat. Right. So that means in degree of 4 will increase by 1, in degree of 3 will increase by 1 because there is an edge coming towards them. Okay, please write that in the chat. Okay. All right. All right. Explain once. Which part, Babu? Balu Sharma. Basically, I'm saying that if there is node 1, okay, if it is having an edge towards 4, let's say it's having an edge towards 3. So basically, in the adjacency list of 1, right, 4 is also present, 3 is also present. So basically, if this is the current node, so when I'll iterate through the adjacency list of the current node, then if this is the ith node and this is another ith node, so I'll increase their in degree, right, by 1. Okay, so to count in degree, we need to create adjacency matrix. No, adjacency list. It will be already given. Like adjacency of 1 having 4 and 3 will already be given to you. Given. It will be given, Vaishnavi. Is it clear? It will be given. We will be given this thing. By default, the program will give you this thing, and you just need to iterate through the adjacency list. Okay. It will already be given to you. All right. So that part is clear. Right. Now, what does this mean further? Right. So what I will do is I'll like initially, can I say that in degree of everybody will be 0 initially? Right. Please write yes in the chat. In degree of everybody initially will be 0. Please write yes in the chat. Please write 0 in the chat. Can I say that in degree of everybody will be 0? Please write 0 in the chat. Quickly comment down 0 in the chat. In degree of everybody initially is gonna be 0. Right. Can I say this? That in degree of everybody initially is going to be 0. right, guys? In degree of everybody initially is going to be 0. Please comment on 0. Right. It is going to get interesting as we go further. Right. Because after this problem, I'll solve another problem that is nothing but, let's say, alien dictionary. So I'll solve that problem also. Right. After this one, I'll solve the possibly the alien dictionary problem. So your it is a hard problem and it will become easy for you. Right. So initially everybody's in degree will be 0. Okay. Now if you will talk about this graph, right? So you will iterate through every node. Let's say if you start from 0, right? So does 0 have anybody in its adjacency list? I don't think so, right? So from 0, is there any edge going towards anybody? Please write no in the chat, right? From 0, is there any edge going towards any node? No, no, you cannot say that. No. So in that case, you will say that that is fine, right? So it does not increase any in degree of anybody, right? So I will obviously have in degree of, let's say, 0. Okay, then I'll say that, okay, in degree of 1. Okay, in degree of let's say 2. Okay, then I'll say that, okay, in degree of, let's say, 3. In degree of, let's say, this node 4. Okay, then in degree of this node 5 is there, and initially all of them will be marked as 0, obviously, and so I'm not writing this thing up, right? So now if I'll see for this node 1, okay, now for 1, is there any edge going to from 1 to anybody? Please write no in the chat. Please quickly comment on no in the chat. Is there any edge going from 1 to anybody? Right? No, no, there is nobody in the adjacency list of 1, right? So 1 does not increase the adjacency in degree of anybody. Okay, now after that, if you will look at the next node, so 2, if you will look at this node 2, so does 2 have anybody in its adjacency list? Yes, in the adjacency list of 2, 3 is there, right? From 2, there's an edge going towards 3. So that is why in degree of 3 will increase by 1. Okay, in degree of 3 will increase by 1, right? After that, if you will look further, right, if you look further, so 4, this node 4 is there, right? So if this node 4 is there, so 4 is having an edge towards 0 and 1, right? So their in degree will increase by 1 each, right? After that, if you will look further, right, so we are iterating through all the nodes one by one, and now 5. So 5 is having an edge towards 2 and 0, right? So 2's in degree will increase by 1. Okay, and then the in degree of 0 will also increase by 1, so it will now become 2. Is it clear to everyone? Is it clear to everyone? Is it clear to everyone till this point? Is it clear to everyone? Yeah, is it clear to everyone? 0 and 1 has in degree 2. Yeah, 1 also has the in degree 2. Yes, because yeah, see, if you will see 3, so 3 is having 1 in its adjacency list. So 3 is having an edge towards 1, right? So that is why in degree of 1 will increase by 1 more, so it will be nothing but 2 here. Okay, yeah, 1 has in degree 2. I missed this, right? Is it clear to everyone till this point? Right, that's how we develop the in degree part. Right. Now for the other nodes, the in degree is 0. Right. In the in degree is 0. Okay, this particular point is there. If you are clear till this point, is everyone clear or any doubts is there? If you all are clear, please give me a +1, or you can write proceed, P for proceed in the chat. Then I'll proceed further as well. Is everyone clear till this point or not? Is everyone clear with this particular point or not? Okay, so all right, uh, great. Okay, great. Now, like if you will see here, right, if you will see here, so can I say that 5 is not, 5 is independent, right? If you will see, there's no edge coming towards 5, so 5 is independent, right? Please write IND in the chat. 5 is independent. Similarly, 4 is also independent, right? 4 is also independent. Correct, 4 is also independent, right? So basically topological sorts means that, okay, whichever persons are independent, you will have them in one by one. Okay, right? So basically what will happen here, see, like these people are independent, right? So topological sort can be of various ways, right? Either you can do first of all 4, okay, then you can do 5, or you can do 5 then 4, right? Is that clear? And then rest of the things will follow. Please write 2 in the chat. There are two ways to start, right? Please write 2 in the chat. There are two ways. Either you can have 4 then 5, or you can have 5 then 4. Both are valid. Is it clear? You can do 4 also, for like in the very first you can do 4, or then you can do 5, or you can do 5 then you can do 4. All of like both of them are valid for me, right? But I will try to do what I will try to have it normally only, right? So what I'll do is I'll iterate through the from like I'll iterate. Okay, so what I'll do is I'll have a queue for myself. Okay, I'll have a queue for myself, and this queue looks like this, right? This queue looks like this for me. Okay, now what I will have is whichever node is having the in degree as 0. Okay, which nodes are there initially that have the in degree as 0? Please tell me, guys. Which nodes are there that have the in degree as 0? Please tell me. Please quickly comment down. Which part you are not clear with? Okay, okay. I am basically saying that there can be can be many topo sorts, right? Many topo sort order, topo sort order. Okay, like if I talk about normal orders, right? So if I talk about normal sorting, so there is only one ascending order or one descending order. But in topological sorting order, there can be many orders. Okay, there can be many orders. Like if I'll give you one basic example, right? So let's say this is one. Okay, let's say this is three. Okay, let's say this is two. Right. So guys, can I say that maybe I can do one? Okay, then after that I can do two, and then I can do three, because if I do one, okay, then after that I can do two, and after doing two, then I can do three. Okay, this is one way, right? This is one way. Like the first way is of this kind. Now another thing that I could have done is maybe I can do two first of all. Okay, then I can do one, and then I can do three. So basically there can be many topological sorts, right? So I need to return any, like is that clear to everyone? There can be many topological sorts. Is that clear? That is what I wanted to explain. Like either I could have done one first of all, so this dependency reduces, then three also needs two to be done, so I'll do one, then I'll do two, then I'll do, then obviously I can do three, or I can do two, then I can do one, right? I can do two first, then I can do one, and then three will be independent, so I can do three. Is that clear? This reminds me striver. Okay, uh, thanks a lot. Right, is that clear to everyone till this point, guys? Is everyone clear till this point? I hope that you are. Please give me a plus one in the chat if you are clear till this point, right? So there can be various way, like orders of topological sort. That is what I was saying only. Okay, this is the thing, right? There can be many topological sorts. That is what I was saying. Anjali, is that clear? Like, sorry, Vaishnavi, is that clear to you as well? I hope that you are clear. Rishit, are you clear with this? Other people are also clear with this, right? So initially, what I'll do is I'll have a queue for myself. Okay, I'll have what? I'll have a queue for myself, right? Let's name it as queue. Uh, let's have this queue, right? So I'll have this queue, and what I'll have is, let's say this is the queue that I'm having. Right. Now, what I will do here is I'll iterate through this list, and all the people that are zero, I'll keep on pushing them inside, right? So I'll push this guy, I'll push this guy. Please write 4, 5 in the chat, right? I'll push 4, I'll push 5. That is what I'll do. Right. Initially, that is what I'll do. Right. Now what I'll do is now what I'll do is after that, right after that, what I will be doing is basically, if you will see here, now I'll take the front guy out, right? So what's the front guy? Now, can I say that the front guy is nothing but 4, right? So what I will do is I'll say that, okay, if that is the case, so I'll have this guy 4. So basically inside my answer, right? Inside my answer, I'll say that, okay, let's pick this guy 4. I'll pop it out from the queue, okay? And what, like in the adjacency list of 4, which people are connected, guys? Tell me. Can I say that in the adjacency list of 4, 0 is there and 1 is there, right? Okay, can I say this? Can I say that if 4 is getting done, right? So indirectly the dependency of 0 and 1 reduces by 1, right? What do you think? If 4 is getting done, then 1 in degree of 0 is reduced, and 1 in, if 4 is getting removed, if I'm doing the task 4, then 0 and 1 are getting 1 in degree less. Yes, right. So that is why I'll reduce the in degree of 0 and 1 by 1, right? So what I'll write here is I'll simply write a 1 1. Okay, so that is what I'll do, right? Now, obviously, you can see that this particular thing has been done, right? Now, after that, what's the next guy? So, and also one more thing. Sorry, one more thing. Like I'll say that, okay, I was at 4, right? Once I've done 4, right? So now I'll see, right? I'll see. So basically, I reduce the in degree of 0 by 1 and in degree of 1 by 1 also, right? So does the in degree of 0 become 0? Does 0 become independent? No. In degree of 0 is still 1. Does the in degree of 1 become 0? No, it is still not independent, right? So that is why I'll push nothing inside the queue. Is it clear? Still the in degree of 0 is still greater than like is still greater equal to 1. In degree of 1 is also greater equal to 1, so they are still dependent, right? So what I'll do is I'll say that, okay, everything is fine, right? Do we need to start from the node which has 0 in degree? Yes. So initially, yes. Okay, is this point clear to everyone? Like I'll see that, okay, like in degree of 0 is still greater equal to 1, in degree of 1 is also greater equal to 1, so I'll push nobody inside the chat, like sorry, I'll push nobody inside the queue, right? If anybody has in degree 0, then only they will be pushed inside the queue. Is it clear? Please write push in the chat if you're clear with this thing, or plus one also, and hit the like button if you're clear till this point, guys. Is everyone clear till this point? Quickly let me know, guys. I hope that all of you are getting this much sense. Is that clear to all of you? I hope that it makes a lot of sense to you, right? Okay. Then what I'll do is I'll have this node 5, right? I'll have this guy 5. So now 5 is there, right? So I'll pop out 5. So basically I can say that now 5 will be put here by me, right? Then if 5 is getting resolved, right? So what are the, in the adjacency list of 5, what is happening? In the adjacency list of 5, I'm having this node 2 and I'm having this node 0 as well, right? I'm having this node 2 as well as 0, right? So in degree of 2 will reduce by 1. So in degree of 2 will now become 0, right? So now can I say that push 2? Please write push 2 in the chat. I'm having this 5 is connected with 2, and if 5 is getting done, so in degree of 2 reduces by 1, right? So basically what will happen in degree of 2, like in degree of 2 will reduce by 1, so in degree of 2 now becomes 0, right? So now I'll push 2 inside. Please write push 2 in the chat. Please write 2 in the chat as a respect for 2. Please write 2 in the chat, guys. Please write 2 in the chat. Basically now the degree of 2 is becoming 0, so that is why I'll push it inside the queue. Is that clear to Vaishnavi? Is that clear to Shivam? Is that clear to Rishit? Is that clear to Kiki? Is that clear to Dev? Is that clear to other people also? Please write 2 as a respect sign for this, right? As a victory sign, please write 2. Okay, so that is what is being done now in degree of I'll say that, okay, this guy 0 is also there in the adjacency list. Okay, so 0 is its in degree also will reduce by 1, so it will become 0. So please write 0 in the chat. Now 0 will also be pushed inside the queue, right? 0 is also going to be pushed inside the queue. Is it clear to everyone, guys? I hope that test makes a lot of sense to everybody. We are pushing the nodes when the in degree becomes 0. Yes, that is what we are doing, right? That is what we are doing. Okay, this is what we are basically doing. Okay, so that is what we will be doing, right? Now after that, now we'll move next up, right? So next, which is the node present? Like I'll say that, okay, 2 is present, so I'll say that, okay, let's have it in my answer. Now since I'm having 2, so in the adjacency list of 2, right, it is having 3 only, right? So 3's in degree will reduce by 1, so it will become 0, right? So in that case I'll push 3. Please write 3 in the chat. In that case I'll push 3 inside the queue. Okay, that is what I'll do, right? Please write 3 in the chat. Okay, so I'll push 3. So this guy gets removed and I'll push 3 inside. Right. Now after that, what will happen next? Right. So I'll have 0. So now if 0 is getting done, so I'll put 0. And in the adjacency list of 0, there is nobody. Right. So it will not reduce the integrity of anybody. Move now to the code. Yeah, I'll move to the code very soon. Right. I'll move to the code very soon. Right. After this, what will happen? I'll move to the next node. So I'll move to this guy 3. Okay, so now when I'm at this guy 3, right? So 3 is having 1 in its in the adjacency list of 3. I'm having 1, right? So in that case, the adjacency list of 1 will reduce by 1, so it will become 0, right? So then I'll push 1 inside. Okay, then I'll push 1 inside, right? So after that, 3 is added to my answer, and I'll push 1 inside, right? So then what will happen? Then what will happen? After that, after this process has been done, right? So again, you will see that you can see that now I'll have 1 inside. So I'll take out 1. In the adjacency list of 1, there's nobody, right? So nobody will get relaxed, obviously, and I'll put 1 here as well. So that is what I'll get as a topological sorted order. You can see here that after this, the queue will become empty, and the topological sorted order will be nothing but 4, 5, 2, 0, 3, 1. Okay. Is it clear to everyone? Is it clear to everyone? Is it clear to everyone? First of all, see, you can do 4, right? If you do 4, then this much part gets reduced. Okay, then if I'm doing 5 as well, then this much part gets removed. Then either I can do 0, or I can do like 2, or I can like see in that case I can do 2 or I can do 0. So let's say I'm doing 2. So if I'm doing 2 also, then after that let's say I'm doing 0, because 0 is also independent, 3 is also independent. So I'm having 0 here, then I'm having 3 here because 3 is also independent. Okay, then I'm having after doing 3, 1 also becomes independent. So this is the topo sort order. Okay, is it clear to everyone? Please tell me, guys. Is this point clear to everyone? Please let me know, and then I'll proceed further with it as well. Okay, is that clear to everyone? I hope that this makes a lot of sense to everybody, right? Please write clear in the chat, and then I'll proceed further as well. Okay. Right. So basically, what is the size? What is the size of this? Right. The size is what? The size is 5. Sorry, the size of this, the size of the final answer is what? 6. Right. So everybody gets independent, right? like these are all the people that are independent, right? So in the end, all the 6 people get independent, right? There were 6 nodes. These were 6 nodes, right? And in my final answer, I'm also containing 6 nodes, right? So that means there is no dependency. Please write no. In the end, there is no dependency, right? So everything gets resolved. Is it clear? Everything gets resolved. Is it clear to everyone? Everything gets resolved. Is it clear to everyone? Please let me know, guys. Then I'll proceed further. Is it clear to everyone? Please hit the like button if you are clear till this point. Okay. Okay. Please hit like. I'm requesting, highly requesting that you can hit the like button if everyone is clear till this point. Okay. Please hit like, and then I'll proceed further. If you are clear, let's see that if we can get 135 likes or not. Let's see. If you have understood till this point, please write. Please, let's get 135 likes, and then I'll show you the code also. Let's see if we can get to 135 likes or not. So you can count with along with me that one, let's say 2, 3. Okay, I'm still counting. Okay, so we have reached 135 likes. Let's try and make it 140. But before that, I will obviously show you the code. So please write code in the chat. Okay. Now I'm going to show you the code for Kahan's algorithm. Okay, I'm going to show you the code for the Kahan's algorithm. Can we see the code for the Kahan's algorithm? Can we see the code for the Kahan's algorithm, guys? Yes or no? Quickly let me know. I hope that we can. Can't like double. Yes, double like is not possible. Only one like per person is allowed. Okay, okay. So can we have a look at the Kahan's algorithm code? Okay. So let's have a look at it. Okay. Can I show you the code directly? It will save us some time. Okay. So that we can look at other things also. So just give me a second. I'll copy this code. I have already written it. So I think that we can see that will be better. So if I'll write the FG right here. All right. Let's have this. And let me remove this part. Let's have it here. Let's paste it. Okay. So see what I'm doing, right? In the end, I have to return the order. Please write order in the chat. Okay. In the end, I have to return what? In the end, see, I have to return the list. Okay, list of the topo sort, right? List of the topo sort. List, or you can say order. You can say in the end, I have to return the list or the order of the topo sort. Of the topo sort. Let's say. Right, let's say that. Okay. In the end, I have to return the list or the order, right? So if like see if the list size, right, if let's say that if I talk about this thing, right, so if I'll talk about this thing, guys, understand this thing, please understand this thing, right, please understand this thing, right. I'm saying that if let's say that I had 5 courses, okay, and in the like let's say if I had 5 courses that were from 0 1 to 3 4, okay, if these were the courses that I had, okay, if I had the courses from 1 to 4, like 0 to 4, okay, and in the list, in the final list, okay, in the final topo list, okay, if I only had, let's say, 4 elements, let's say if it was 2, let's say it was 1, let's say it was 0, and let's say it was 3, right, if the size of the this is 4, right, so in that case, if I had 5 courses, okay, if I had 5 courses, and in the topo sort order, I'm only getting 4, right? So can I say that for one guy, the dependencies is still there? That is why it is not here. Please write yes in the chat, right? That means all the people are not independent, right? Let's say, right? So in that case, we will say that, okay, it is not possible. The topo sort order is not possible for it, right? If I had 5 courses, right? So all the 5 courses should be present in my final answer. If I had 5 courses, then all 5 courses should be present in my final answer. Is that clear? Please give me a +1 in the chat, and then I'll proceed further with this. Please quickly give me a +1. Okay, and hit the like button as well if you're clear with this, right? So is it clear? Please write clear in the chat. Please write clear. Please quickly write clear, because this is very important. That is what I'm expecting. Nothing less than that. Okay. So I think people are clear with this, right? So see what I've done. Let me show you the code part here, right? So what I'm having is I'm having a list, right? So that will store the final answer. Okay. Then I'm having this in degree 0, right? Initially, I'm marking everybody's in degree as 0, right? Initially, I'm marking everybody's in degree as 0. Then I am iterating for all the nodes, and let's say if I'm at the if I'm at adjacency of 0, right? So I'll if I'm at the adjacency of 0, right? So all the nodes that are present in the adjacency list of 0, right? Let's say 1 is present, 4 is present, 5 is present, whatever. So they are the children, right? They are all the children, right? So for them, I'm increasing their in degree by 1. Please write +1 in the chat if you're clear with this thing, right? Initially, I'm increasing the in degree, right? Is that clear to everyone? Like initially I'm increasing the in degree of everybody, right? whichever edges are coming towards everybody one by one, I'm increasing their degree, right? Is that clear? Please give me a +1 if you're clear with this point, right? Is everyone clear with this point? Quickly let me know, guys. Okay, Shinu says yes. What about others? What about others? Others are also clear? Okay, then since Kahan's algorithm is based on the BFS logic, right? It is based on the BFS logic, best first search, because it uses a queue, right? So that is why what I will do is I'll have a queue for myself. Okay, and please write push like we will push what? We'll push all the people. We'll iterate through all the nodes starting from 0 till v-1, right? Till v-1. We'll iterate through all the nodes, and if the in degree is 0, right? So we'll push it inside. Is that clear? We'll iterate through all the nodes. If the in degree is 0, then we'll push it. Okay. Now, while the queue is greater than 0, right? So I'll take out the current guy from it, right? While the queue size is greater than 0, then we'll take out the current guy. Okay. We'll pop it out. We'll push it inside the answer, right? So currently we'll take out the front guy. Okay. Then we'll remove it from the stack. Okay. We will take out the current guy from the stack, right? From the queue, sorry. Then I'll pop it out. Okay. Out of the stack, right? Pop it out of the queue, sorry. Pop it out of the queue, right? Pop it out of the queue. Then after that, what I'll do is I'll push it in the answer, push it in the answer. Okay. And then since this guy is getting resolved, right? It is getting resolved. So dependency decreased by 1. Please write -1 in the chat, right? Please write -1 in the chat. Right. Now, if I had a particular guy currently with me, right? So if I'm doing that, like if I'm having that guy, right? So as I said, if I'm having that guy, so all the children that are there, their in degree will reduce by 1. So please write -1 in the chat, right? Okay. So all right. So I'll decrease the in degree by 1. Okay. And if the in degree becomes 0, then I'll push the child. And in the end, I'll return this list, let's say. Is that clear to everyone? Till this point, everyone is clear? Okay. Is everyone clear till this point? Quickly let me know. Is everyone clear till this point? Then I'll proceed further and we'll do another problem. Is everyone clear? Samar, okay. All right. Okay. So Kahan, this was all about Kahan's algorithm, guys. Okay. Similar code goes in Java also. If I'll show the Java code, tell me medium problem. Tell medium problem, yes. Now we'll see the medium problems as well. So again, similar code goes in Java as well. Okay, now it's clear. All right. So let's do one thing. Like let's discuss one of the problems. Please write. Like, can I see this? Okay, I have closed the whiteboard once again. I don't know why. So I'll open it again. Okay, I'll open the whiteboard again. But Java code, many beginners here. Okay, so I'll try to share it with all of you. Don't worry. Okay, now please write dependency in the chat, right? Can I say this, guys? Can I say this? Can I expect this? That dependency thing is there, right? Dependency, right? Please write dependency in the chat. Please write DEP in the chat. When I say topological sort, right? Topo sort. So the things that comes to my mind is nothing but dependency. Please write dependency in the chat. When I think about topological sort, then the thing that comes to my mind is dependency, right? Whenever I'll see anything dependency, right? Whenever I'll see anything like dependency, right? Then topological sort is going to come to my mind whenever I'll think about dependency. Okay, right? Let's do one problem. Like let's quickly have a look at one problem. Okay, alien dictionary. Let's have it. ALIEN, alien. ALIEN DICTIO. Let's have a look at this problem. Okay, alien dictionary. So it has been asked in a lot of companies, to be honest, right? Please write hard in the chat. Please write hard OP in the chat. You can see now I'm going to solve this problem for you. That is nothing but alien dictionary. This problem is nothing but a hard problem, right? So please write hard in the chat. Okay. The problem name is alien dictionary, and it is a hard problem. And to be honest, it's kind of on a harder side, right? So if you are as excited as I am, so please hit the like button, and then I'll proceed further with this one as well. Okay. And let's make it to 160 likes. Okay, let's see if we can reach there or not. Okay, uh 160 likes. Can we get somewhere closer to, let's say, 160 likes or not? Can we get close to 160 likes? Let's see. I'll still be counting. Okay. So please tell me, can we reach 160 likes? I'll count. Let's say one. Okay. Then two, three, four. Okay. Last counting, five. Okay. So how much did we reach? Still 150. Okay. Let's see. Let's see if we can reach 160 likes today or not. Okay. Uh, all right. So at least we reach one. Like, can we reach 155? Let's see. Let's see. Still, I'll wait for 1 or 2 minutes. 1 minute. Let's less than 1 minute. Let's say. Okay. Great. Please don't start disliking. Okay. Now let's see forward. Right. So see, this problem has been asked in Amazon. Okay. This particular problem has been asked in Amazon. Right. It has been asked in Google. Right. It has been asked in Amazon, Google. Then it has also been asked in Microsoft. Right. Then this problem has also been asked in Oyo. Right. Then it has also been asked in Walmart. Right. And then it has also been asked in Flipkart. Okay. But there's one thing that's very important, the dependency thing. Please write DEP in the chat. The dependency thing is still there. In this problem also, the pattern that you have to observe is the dependency. Is it clear? Once you crack the pattern, then things are fine. Okay. Please write DEP in the chat and then I'll proceed further. All right. Can we proceed further? Okay. Just give me one more minute. Let's say that. Let's start now. Okay. So now let's do one thing. Like tell me one thing, guys. If you will tell me one thing, right? If you have like let's say if we talk about alphabetical, like if we talk about a dictionary, right? Let me change the color of the pen. Let me reduce the size of the screen also. Okay. Let me tell you this thing, guys. Let me tell you this thing. Have you seen a dictionary, right? Have you seen a dictionary? Yes. Can I say that inside a dictionary there's a dependency, right? There's a dependency that okay, after A, like before B, A has to come, right? So B is dependent on A, B is dependent on A, then C is dependent on B, right? Then D is dependent on C, then E is dependent on D. Yes or no? Please write yes in the chat. Have you observed this thing? Please write yes in the chat. Have you observed this thing in a dictionary that okay, this is what the dependency looks like, right? In a dictionary order, like alpha, basically this is what alphabetical order, right? This is alphabetical order. Yes or no? Basically, before B, A has to come and all that. Yes, there's some dependency, right? There's some dependency here. Okay, so there's some dependency here. In the like, as I said, let's say if we have this word, like let's say we have this word, right? If we have this word here, Vanshika, right? So let's say we have this word Kunal. So which guy is going to come before? Please tell me, guys. Please tell me. Please quickly comment down which word is going to come before. Which word is going to come before? Which word is going to come before? Please quickly let me know. In the chat, please quickly comment. Please quickly comment which word is going to come before and why. Can I say this thing? Can I say this thing? That K is dependent, like V is dependent on K, right? Can I say this, that V is dependent on K? So basically what will happen? What will happen? I'll have Kunal, right? And then after that, I'll have Vishal. Sorry, one second, right? Just a second. Right, right. That is what I'm going to have. Is that clear? Right. So K is like V is dependent on K. Right. V is dependent on K. That is clear. Right. So now you have this aliens, right? So this is what our dictionary look like. This is the normal dictionary, right? This is what is this? This is the normal dictionary. Right. Please write N in the chat. Please write N in the chat. N means normal. This is nothing but normal dictionary, normal real life things. Right. This is nothing but a real life thing. Correct, guys? This is what this is nothing but a real life basic thing. Correct. Okay, and hit the like button also if you are clear till this point, guys. Okay, this is nothing but a normal thing, right? Please hit the like button if you are clear till this point. Okay, now moving further, let's see this particular dictionary, right? So these people are saying that they will have keywords, right? These people are saying that you have been given a sorted dictionary. Okay, so these people have given you a dictionary, like this kind of dictionary has been given. What is the dictionary? The dictionary looks like BAA. Okay, then you have sorry, don't know why just working like this. Okay, so you have BAA in the dictionary. Okay, right after that you have ABCD. Okay, then you have ABCD. Okay, then after that you have ABCA. Okay, you have AB, then you have C, then you have A, right? Then you have CAB, right? Then you have CAB right here, and after that you have CA and then D. Okay, that is the scenario here. Okay, now if I talk about a normal thing, right? Let's say if I talk about something like this, let's say ABHINAV, right? Abhinav, right? Then after that, let's say if I'll talk about Siddharth, right? Siddharth, right? Then I'll talk about Yash, right? So I can say something of this kind, right? So A is having an arrow towards S, then S is having an arrow towards Y, right? Basically, S is dependent on A and Y is dependent on S, right? This kind of thing, right? This is what our dictionary looks like. But how does their dictionary look like, right? So this is the dictionary that they have given. Okay, they have given, please write given in the chat. This is the dictionary that they are having. Okay, this is the dictionary that they are having. Okay, now what we need to tell is like there are only k words. You can see that here the k value is 3, like sorry, k value is what, 4, right? Because there are only 4 words, right? There's A, there's B, there's C, there's D, correct? Yes or no, guys? Right? Here you are having only 4 words. There's A, there's B, there's C, there's D, right? Sorry, 4 characters, right? 4 characters, right? Yes or no, guys? Here we only have 4 characters. Yes or no? What do you think, guys? Don't you think the same, that here we have 4 characters? Correct, guys? We have 4 characters right here. I hope that is the case with us. We are only having 4 characters here, right? Okay, so that is what they mean by k. K is equal to 4 means there are 4 characters. If you will look at the next example, so you can see that k is given as 3. So you only have 3 different characters. A is there, B is there, and C is there. Right, that is what it looks like. Right. So what you need to tell is, you need to tell whether this is valid or not. Right. Right. You need to tell whether this dictionary, okay, whether this dictionary is valid or not. Right. Is valid or not. Right, valid or not. If it is valid, then you need to return the order, right? Then you need to return the order. Okay, like if I'll have a normal dictionary, then you will say that okay, in the normal dictionary the order will be A, B, C, D, right? But this particular dictionary does not follow this order. Please write +1. Are you clear with this thing? This dictionary is not following the normal alphabetical order. Please give me a +1 in the chat. Okay, please give me a +1 in the chat. This dictionary does not follow the normal order. Okay, this dictionary is not following the normal order. Okay, now you can see that there are many cases. Please write many in the chat. Are you clear with this thing? There can be many topologicals, like if I'm talking about some dependencies, right? So there can be many orders in which the answer can be possible. When you see many orders, so you are also clear with this thing, that okay, many orders will be there, because if I talk about toposort, so obviously there can be many orders for me, right? That can be the one of the possibilities, right? So if I will see here now, how can I do this, right? How can I do this problem? So at one point of time, please write 2 in the chat. I'll check 2 characters. So let's say what I do is, let me increase the size. Okay, just a second. Okay, so let's say if I'm having these 2 characters, right? If I'm having these 2 characters, so what I'll do here is I'll check these 2, right? I'll check for these 2, right? I'll check for these 2. Now, which is the between these 2 strings, which is the first character that is different? Please tell me. Between these 2 strings, which is the first character that is different, right? If I have BAA, okay, and I have ABCD. If I have BAA, right? If I have BAA and ABCD, so can I say that? The difference is here, right? Can I say that the difference is here? What do you think, guys? Right, between these 2 strings the difference is here, right? So can I say that B is uh, like A is dependent on B? First of all, in this dictionary B should come before A. That is why BA is coming before ABCD. What do you think, guys? What do you think? Please tell me, agree with me? Please write agree in the chat. Everyone agrees with me? Please write agree in the chat. Right, that is the thing. If BA is coming before ABCD, so that means B is having arrow towards A. That means A is dependent on B. Is it clear? Please write agree in the chat. Do you all agree with me on this point? Please hit the like button if you agree with me on this point, right? Does everyone agree on this point? Please tell me. Does everyone agree with me on this point? Okay. Okay. Does everyone agree on this point? Okay. So I'm having an edge from B to A, right? So this is how you look alphabetically, right? Then B is having an edge towards A. I'm fine with that. Okay, now let's have a look at the other things also, right? Now let's have a look at the next two characters, right? Again, please write two in the chat. Again, two at a time, right? Now, yeah. So basically, A is dependent on B. Now, basically, from like when you will do B, then only you can, when you will put all the characters starting with B, then you can put A. Now that is the thing. If you are putting B A before A B C D, so that means you are putting B before A, right? So that means B is before A. So A is dependent on B indirectly, right? That is the case here, right? That's clear. That's clear to everyone. Right, now please write next two in the chat, right? Next two, N2 in the chat. Now I'll check for the next two character, next two words. Okay, next two set of words is what I'll look at. Right, now let's have a look at them, right? Let's have a look at them. So I'm having A, B, C, D. Okay, I'm having A, B, C, D right here. And I'm having A, B, C, A. Right, that's what I'm having. So if I look at the positions, right? So which position is different? Can I say that A is the same, B is the same, C is the same, but D is there and A, right? So the difference comes here, right? The difference comes here, right? Can you see this? Okay, can you see this, guys? Uh, Also, one more thing. Let me do one more thing, right? Let me just open one YouTube video. Okay, just give me a second. VFG practice. Just a second. I will open this. And what I need to do is I will be doing this stream today. Okay. So what I will do is I'll just put that hi. Uh, okay. Week one, we will start at around, like we'll start around, okay, and 11, 10, let's say, okay, 11, 10, okay. So that is the thing, because I'm doing this problem as of now. Why N2, but why? Sir, why N2? Because basically I'm comparing two adjacent characters at a time. That is what I was saying, I think, right? King, I was saying this thing, right? Is it clear to Rishit? Is it clear to everyone else, right? Till now, right? Like, see. So in that case, can I say that? Can I say that from D to A? Please write DA in the chat if you're clear with this thing. That D should come before A. So basically, D will come. D is having an arrow towards A. What do you think, guys? What do you think? What do you think? What do you think? Yes or no? What do you think? What do you think? Right? D is having an arrow towards A. What do you think? Like I'm saying that if ABCD is there, right, and then ABCA is there, so why is this character, why is this word coming before this? Because this is same, this is same, this is same, but this is different. So basically D is coming before A. So basically D is coming before A. So A is dependent on D. Is it clear? Now Prahalip Kaur, is that clear now? Does it make some sense now? Yes or no? Okay. Right. So D is having an edge towards A. Kaur, are you clear with it? Prahaleen Kaur, sorry. Are you clear with this? Okay. Right. Then I'll check for the next two characters, right? So I'll check for these two, right? Just give me a second. Let's change the color, right? I'll check for these two. Now, what are these two characters, right? Let's have a look. So ABCA, okay, and CAB, Cricket Association of Bengal, right? So A, these two characters, these two words are in this order. So basically, A is having an edge towards C, right? Please write AC in the chat, right? Now, A is having an edge towards C because C is dependent on A, right? C is dependent on A, right? Is that clear? Is that clear to everyone? C is having an edge towards. Is that clear? Is that clear to everyone? Right. Now, moving on next. Moving on to the next part. Moving on to the next part. So, next part is what? This part. So, if you will see here, right? So, I'm having CAD. So can I say that in this particular sequence, right, in this particular sequence, B is coming before T, right? So B is having an arrow towards T, right? So basically, this kind of thing is there, right? This kind of thing. Okay, is that clear? Is that clear, guys? Is that clear? Is that clear? Please write dependency OP in the chat, right? Are you clear with this thing? You can write DEP OP in the chat, right? Dependency OP. Now this is what? This is nothing but, now you need to tell the dictionary order to them, right? The dictionary order will be nothing but the topological order, right? Okay, so for this you need to tell the topo order, basically topo order, right? The dictionary order, right? You need to tell the dictionary order for this case. Okay, so you can write dependency OP in the chat, guys, right? Basically this problem is based on dependency. Now you have a graph. Let's say now you can build this graph, right? I hope that, because if these characters are different, so this and this character is different, so basically in the adjacency list of D, okay, I'll be having a right? I'll be having A in the adjacency list of D, and similarly, let's say in the adjacency list of B, right? In the adjacency list of B, I'll be having A and I'll be having D as well, right? Is that clear to everyone? Right, that is what I'll be doing. And once I have the once like please write ADJ in the chat. You can you build this adjacency list? Yes. In the adjacency list of D, you will be having A. In the adjacency list of B, you will be having A, B, A, D, right? Is that clear? That is whenever you get different characters, so you can put it like that. Is that clear to everyone? Is that clear to everyone? Please tell me, guys. I hope that it makes a lot of sense to you. Right, that is what you will do. Once you like, the first step will be that you will build the adjacency. Please write ADJ in the chat if you are clear with this thing, right? First thing is that you will build the adjacency list, right? So if let's say these characters are different, so this is different, so this is different, these are the characters that are different. So basically B is having arrow towards A, so in the adjacency list of B you will push what? A. That is what you will do. So that's a very simple thing, to be honest. You can build the adjacency list, right? Once you have the adjacency list, then you can do the in degree, you can calculate the in degree, right? Then after calculating the in degree, what you can do is you can apply the to like Kahan's algorithm. Okay, once you have applied the okay, right? Once you have applied the Kahan's algorithm, then you can check if the size of the answer, right, is equal to K, right? If the is equal to K, so if the dependency is resolved, then it is valid, right? Else not valid. Else it is not valid. Not valid. Not valid alien dictionary. Not valid alien dictionary. Is this point clear to everyone? If we are not able to resolve all the nodes, then it means that the dictionary is invalid. Yes, definitely it's invalid, na? Because let's say if I'll draw something like this for you, right? Let's say that what I will do is I'll show you one example for invalid as well. Now, see, if I'm having, let's say, C, okay, then let's say I'm having A, B, C. Okay, let's do one thing. Let's strict this a little bit more, right? Let's say that I'm having what? Uh, CB. Okay, then I'm having CAB, something of this kind, let's say. Okay, so in that case, if I'll compare these two, right? So if you will see here, right? Let's say if I'll compare these two. So in that case, I can say that B is having an edge towards A. Okay, then after that, if I'll see the next one, right? So if I'll see these two, so I can say that okay, A is having an edge towards C, right? A is having an edge towards C. If you will see further, right? Let's say that if I build up something on top of this, let's say if I have a list and I make B, C, A, something of this kind, right? Let's say. So if I'm comparing these two now, right? So in that case, C is having an edge towards B. So this is cyclic, right? And then the dependency will not be resolved. So is it clear when it will not be there? Sir, Hindi में बोल लीजिए please. I like to speak in English. I'm more fluent in English compared to Hindi at times when I'm speaking a lot. And you will be giving interviews in English only. Is it clear to everyone, guys? Please let me know. Is it clear to everyone? Is it clear to everyone? Till this point, everyone is clear or not? Please tell me, guys. Is it clear to all of you? Is it clear? Is it clear? Did you learn something new? If you learned something new, please give me a +1, right? So that is what you will do in that one, right? You can build the adjacency list. Okay, then you can have the in degree. Then you can apply the Kahan's algorithm. If the size of the answer is equal to K, then it's valid. Otherwise, it's not valid. These things are there. Is it clear to core? Is it clear to other people as well? Please hit the like button and give me a +1, guys, if you are clear till this point. I hope that it makes a lot of sense for all of you. Okay, does it make some sense, guys? I hope that it does makes a lot of sense, right? Okay, so please tell me if you are clear, right? Also, I'll show you my submission. If you are clear, please hit the like button. Okay, the only thing that I am expecting now is you can hit the like button. Hit like. If let's say hit like if you enjoyed the session, or you can say learned from the session. Okay, so this is what we did today. Just quickly hit the like button, guys. I'm still here for some time, right? Obviously, I can show you the code also till that point, but I just wanted to convey one of my words, right? So let me have a look at the GFG ID. I hope that you enjoyed the session. Now let me just do this. The alien dictionary question was nice. Yes, it was nice. So if you enjoyed this question, you can tell me. I hope that you did. In case if you did, please let me know. Okay, all right. So let's have a quick look at the code also, right? So I'll first of all share my code with you. Okay, I'll share my code with all of you. Once I've shared the code, please give me a +1 again if this code is there. Yeah, I was expecting 200 likes, but we were not able to 200 likes. Okay, all right. So it's almost 160, but still not 160. So 160 is 160 only, right? Okay. Let Now let's have a look at the code also. Let us have a look at the code part as well. Uh, is my internet freezed? Not sure. I think it's working fine. Okay, so let's have a look at the code as well. Okay. So see, basically what I've done is I have a adjacency for K because they will be keynotes, right? So I'm having the adjacency list for them. Okay. Now what I will do is I'll iterate through the all the words that are given. Okay. Two at a time. I'll have two words at a time, right? Let's say if I'll have the ith word, I plus one th word, right? So as I said, like if you will look at this particular example, right? Like if I have it here, like I don't know where it is. So basically if I have let's say A, B, C, like then I have B, C, D, whatever. So two words at a time. Like let's say if I have D, B, A, whatever, so whatever I have, right? Let's say DKB, whatever. So in that case, I'll always have a look at the two words at a time, right? I'll always be having two words at a time, right? So I'll check if a character is not equal, if the like if the jth character of the first string is not equal to the jth character of the second string, right? So in that case, this will be the dependency, right? Is that clear to everyone? This is how the dependency will look like, and you will iterate to the minimum of the two, na, right? See, if you will look at this part here, right? If let's say there's one word, like there's one word, let's say A, B, C, D, E, okay, and there's another word, let's say C, A, B. So you will run till here, na, the minimum length will be the minimum. Please write MI in the chat. You will run, like if you are comparing two words at a time, let's say this is the ith word and this is the I plus one th word, right? So you'll compare, if you're comparing, so you'll compare till this point only, till the minimum of the length. Is it clear? Like you only want to, like in that case, you can only compare till this point. Like you can only compare till this point for both of them. You can only compare till this particular point of time. Right? Is that clear? I hope that's pretty much clear to everybody. Right? Okay. Now once that is done, right? So once you build the adjacency list, so you'll mark the integrity for all the keynotes at 0, and then you'll iterate through this adjacency list, increase the integrity of everybody by 1. Okay, and then everything is Kahan's algorithm. Please write Kahan in the chat, and then you will obviously in the end you will just build your answer. So in the, like you are storing in terms of 0, 0, 1, 2, 3, 4 in the notes, but obviously you will have to add a to it so that you can get the final answer and you'll return it. So if I had more time, I would have explained it better, but I think that you can do some research and development on this code. Is it clear to everyone? Guys, quickly let me know. We are running out of time now. Is it clear? Like, did you enjoy this particular session, guys? Yes or no? I hope that you did enjoy this particular session. Did everyone enjoy this session? You can give me a +1 in the chat and hit the like. Let's see if we can reach 160 likes or not. Okay. So I hope that you did enjoy this particular session. Okay, I just hope that you did enjoyed this particular session. Okay, and you learned something new from it as well. Like you learned something new from the session as well. Okay, and dependency OP in the chat. Dependency is a very important thing in life. Okay, so is there any group for discussion? As of now, there is no group for discussion. But if you want to discuss more, then you can basically search for GFG practice YouTube. If you will search for GFG practice, okay, and then YouTube. Like if I'll click on this channel, right? So basically, you can do one thing. You can subscribe this channel if you want more discussions like this, right? Copy link address. So I'll share this with all of you. Okay. If you want to discuss more problems, then you can go to this channel. Okay. So smoothly explained. Karan Patel says, okay. Uh, all right. Really loved it. Okay. So that was it for today. Please make sure to hit the like button, guys, and make sure to share it with your friends as well if it was helpful for you. As I have to take another live at GFG practice right after this session, so I'll be going right there. Till then, thanks a lot for joining for this particular session, and I'll see you in another session. Okay. Till then, it's a goodbye from me for this channel today. Really, thank you because I stuck at graph a lot. Okay. Thanks a lot, Ballu. Thanks a lot for joining, everyone. And I wish that 160 like or 200 likes is what we can reach for this video. Till then, thank you for joining, and I'll see you in another video very soon. Till then, good night. Take care and keep coding, keep hustling. To these days, might be recession is going on, but please make sure to be prepared, and please make sure to practice as much as possible. Don't think about the results. Focus on your hard work. Focus on your dedication. Focus on improving yourself day by day, every day. And with that being said, thanks a lot, and I'll see you on the other side very soon. Thanks a lot, guys. Bye, everyone. Good night. Take care. And make sure to hit the like button. Thank you. And make sure to comment understood as well. Thanks a lot, everyone.